So we are solving JEE Main question paper of 2018 Physics Set-B. Question is 23. The question is, in a collinear collision, a particle with an initial speed of v0 strikes a stationary particle of the same mass. If the final total kinetic energy is 50% greater than the original kinetic energy, the magnitude of relative velocity between the two particles after the collision is. So the question says that there are two particles of similar mass m and m, which initially before collision, the first mass is traveling with the velocity v0 and the second mass is stationary. And after collision, I am assuming that first mass has velocity v1 and the second mass has velocity v2. And we have to find that after collision, what will be v2 minus v1, that is the relative velocity between the second and the first mass. So as you can see, we have two masses in different cases. Let us apply conservation of linear momentum to this problem. So from conservation of momentum, the initial momentum, that is the momentum of both these bodies taken together, will be m v0 plus m into 0, that is 0, so I'm not writing anything, is equal to m into v1 plus m into v2. Removing m, v0 is equal to v1 plus v2. This is our equation 1. Now we need to apply, we can also apply kinetic energy conservation, but be careful for applying kinetic energy conservation. They've given us a specific condition that the final kinetic energy is 1.5 times the initial kinetic energy, is 50% greater, I mean not 1.5 times. The final kinetic energy is 50% greater than the initial kinetic energy. So when we apply kinetic energy conservation, so initial kinetic energy would be half of m v0 square, and the second body's kinetic energy is 0, so this is the initial kinetic energy, and the final kinetic energy is v1 m v1 square plus half of m v2 square, and this is 50% greater than this, so I can write 1 by 2 m v0 square multiplied by 3 by 2 is equal to 1 by 2 m v1 square plus 1 by 2 m v2 square. So solving this a bit, I get 3 by 2 v0 square is equal to v1 square plus v2 square. This is my equation 2. Now if I square the first equation, I get v0 square is equal to v1 square plus v2 square plus 2v1 v2. Now I have the value of v1 plus v2, that is 3 by 2 v0 square. I'm going to put it here. So v0 square is equal to 3 by 2 v0 square plus 2v1 v2. So if we simplify this a bit, we get minus 0.5 v0 square divided by 2 upon v2 is equal to v1, that is minus 0.25 v0 square upon v2 is equal to v1. Now we'll put this value of v1 in the first equation again. So v0 is equal to minus 0.25 upon v0 square upon v2 plus v2. Now multiply the whole equation with v2. v0 v2 is equal to minus 0.25 v0 square plus v2 square. This is a quadratic equation in v2. So where we have a is 1, b is equal to minus v0, and c is minus 0.25 v0 square. Now apply the quadratic formula to this, which will be minus b plus minus root of b square minus 4ac by 2a. This will be the value of v2. If you put and solve it, you'll get V2 is equal to 2.414 V naught. And if you put this in this equation and solve, you will get V1 is equal to minus V naught. Therefore, V2 minus V1, that is the what we require, that is the relative velocity between the second and the first mass, would be equal to 2.414 minus 1 into V naught, which is equal to 1.414 V naught, and 1.414 is also root 2 V naught. That is our final answer, and in the question paper, the option that it corresponds to is 4.
Explore more about the topics you love with Toppr. Subscribe now and keep learning.